In this video, we will work on this problem. So first step, you read the problem carefully and visualize what is happening. Identify keywords, right? So if you read this problem, so I will show you the figure already and you have to draw this figure. Initially, a rod is vertical, right, at rest, and then it falls under gravity. There is a lot of friction at point A. Because of that, there cannot be any slipping at point A, right? So point A is always at rest. So the question is asking, when the rod is at 60 degree, this is 60 degree, at 60 degree angle from vertical, then it is asking, check all the options if they are correct or not correct. Before you start solving it, have an overview of the options to see if they are related in some way. Option A is about angular speed of the rod, speed. Option B and C, they are about acceleration. Option D is about normal force at contact point. So, where is this speed coming from? Angular speed, right? That is coming from gravity. When you take a ball and drop it, as it falls under gravity, its speed is going to increase. So that gives you the hint that gravitational potential energy of the rod is converting into kinetic energy. As you see in the figure, the center of gravity is at this height in the start, and then after 60 degree rotation, it is below. That difference is L by 2 minus L by 2 cosine theta. And that gravitational energy is converting into kinetic energy. IA is the moment of inertia of the rod about point A. And if you solve it, you will get omega is square root 3g by 2L, which is option A. So option A is correct. Part B and C, they are about acceleration. So the first hint is Newton's law, F equal to ma and tau equal to I alpha. A and alpha, they are acceleration. So angular acceleration, so that will be alpha, right? Tau equal to I alpha. So you think about the forces on the rod, mg downward, and at contact point you have friction and you have normal. And here's the thing, if you take the moment about point A, then only mg will create a moment and your calculation will be simpler. So mg, and this distance is L by 2 sine theta, equal to moment of inertia ml square by 3, and alpha is theta double dot, and you will get alpha, this value, and you will see that it is not 2g by L. So B is wrong. Next, radial acceleration. So if you visualize it, radial acceleration, right, you will see it is moving in a circle, right? It will be easier if you just think about radial acceleration is like centripetal acceleration, which is, if you recall, you know it by v square by r, right? And that is v equal to r omega, so it is r omega square, and that's what we do. R is L by 2, that L by 2 is r. And you get radial acceleration is 3g by 4, so C is correct and B was wrong, right? And then part D, normal reaction force from the floor on the rod. So at point A, right? So this is the force diagram, right? And when you say force, you already know acceleration, so you can apply F equal to ma in the direction of n, right? If you apply that, you will get mg, let's say the downward is positive, right? So mg minus n equal to may. Ay is the net acceleration. This is your ay. And you already have calculated AR, right? Radial acceleration, this is part C, right? And AT, the tangential acceleration is L by 2 alpha. Alpha is your part B, right? See how they link, and you plug all that. You take the component in y direction, right? AY, right here, okay? It is AR cosine theta plus AT sine theta in the figure. And if you do that, you will get n equal to mg by 16. You have to be quick in the JEE. The main thing is you have to understand that force, you can calculate it based on part C and part B calculation. So that's how you have to know the concepts.